Like, share and subscribe the channel. Download the Silvervalley Academy app from Play Store or use the link in the description box. Get detailed synapses, multiple choice questions and their answers with shortcuts. An electric dipole of moment P is placed in an electric field of intensity E. The dipole acquires a position such that the axis of the dipole makes an angle theta with the direction of the field. Assuming that the potential energy of the dipole to be 0 when theta 90 degree. Torque and potential energy of the dipole will be. So this theta equal to 90 degree is the standard position where potential energy is assumed to be 0. Okay, done. First we have to find torque. Torque is P cross E equal to PE sin theta. Magnitude of torque is PE sin theta. No issues. Potential energy is given by minus P dot E. So minus PE cos theta. So first is PE sin theta, second is minus PE cos theta. PE sin theta minus PE cos theta. So first. Students, understand the trap here. There are so many lines and you have to identify two equations. So that takes time, but it is actually a simple question. 2 points P and Q are equidistant from a short electric dipole such that P is on the axis and Q is on the equatorial plane. So short electric dipole minus Q plus Q. P is on the axis and Q is on the equatorial plane. Electric field at P is 10 power minus 4. Here electric field is 10 power minus 4. At this point, magnitude of electric field at Q is, this is Q. At Q, it is half of this electric field, 10 power minus 4. So 0.5 10 power minus 4. Half is 0.5, 0.5 10 power minus 4. Why this electric field is half of this? Here expression for electric field is constant 2p by r cube and expression for electric field at Q is constant p by r cube. Of course there is negative sign. Magnitude of electric field is constant p by r cube. See, this is half of this, 2 factor is missing. This is half of this, therefore half of 10 power minus 4 is 0.5 10 power minus 4. If I write vector sign, then there should be vector and minus sign. The electric field at a point due to an electric dipole on an axis inclined to an angle theta, which is less than or equal to 90 degree, to the dipole axis is perpendicular to the dipole axis if the angle theta is. This is related to electric dipole, electric field due to electric dipole. Okay. If this is an electric dipole with minus Q and plus Q, this is some arbitrary point. From the center of the dipole, position vector. So point P, position vector of point P is this, which makes an angle theta with respect to the dipole moment. Direction of dipole moment is from minus Q to plus Q, isn't it? So this is P cap. In this question, this method is, or for this question, this method is used. Okay. This is electric field at P, component of electric field at P along the position vector. You can call it E, along or parallel to the position vector. And perpendicular to this, there is another component. So you can call this E perpendicular component. Resultant of these two. Complete the parallelogram. Draw the diagonal. This is the resultant electric field due to these two charges. This resultant electric field makes an angle theta with respect to the position vector. This is the position vector. Theta is used, right? So let me denote it by phi. Two times tan phi is equal to tan theta. 2 times tan phi equal to tan theta is the equation used. Students, please memorize this equation. 2 times tan phi equal to 2 times tangent of this angle equal to this. Okay. Now come to the problem. This is the dipole. This is point P. It is given electric field at point P is perpendicular to the dipole axis. If this is theta minus q plus q, this is p cap. Okay. This is perpendicular to p cap. These two by construction. And this angle we take it with this sign phi. So 2 times tan phi equal to theta, tangent of theta. But observe, if this is theta, then this angle is also theta. So theta plus phi is 90 degree. Make sure that this constructed line is parallel to the dipole. So theta plus phi equal to 90 degree. So they are asking theta. So let us substitute for phi. Phi is 90 minus theta. So 2 times tan of 90 minus theta equal to tan theta. Tan of 90 minus theta is in first quadrant. Tan becomes cot theta equal to tan theta. Cot is 1 by tan, tan square. So tan square theta equal to 2. Therefore tan theta equal to root of tan inverse of root. Tan inverse of root. So in such problems, make sure that this angle is 2 times tangent of this angle is tangent of this angle. You can use this equation. 3 point charges plus q minus 2q and q are placed at points respectively. The magnitude and direction of the electric dipole moment vector of this charge assembly are magnitude and direction. Now observe x0, y, z0. z0, 0, 0 means concentrate on xy plane. Y axis, x axis, plus q is at 0, a. So 0, a, this is q. Distance is a. Minus 2q is at 0, 0, 0. So minus 2q is at the origin. Plus q is at a 0, 0. a 0, 0. So distance is a. Charge is q. Observe, there are 3 charges. Dipole moment means there should be 2 charges. Find out center of charge of these two. So join these two lines. Center of these two is at this point. This is called center of charge, where total charge is assumed to be concentrated. So this is 2q. This plus this imagined at this point. See, there is minus 2q, there is plus 2q. Two equal and opposite charges separated by this distance. What is the direction of dipole moment? It is from negative to positive, isn't it? So this is the direction of dipole moment. So this dipole moment is not on x-axis or not on y-axis. See, along x direction, no. Along y direction, no. Along x direction, no. So we have to decide between these two. Now q into a is the dipole moment. Here root 2 qa. This is 45, this is 45. Therefore this should be 45 and this is 90. If this is a and this is a, this total length is a root 2. Then this length is half of this. By 2 means a by root 2. So this length is a by root 2. This length is also a by root 2 because isosceles right angle triangle. So this distance is a by root 2. So dipole moment is charge is 2q into distance between the charges is a by root 2. So root 2, 2, it is root 2 q a. So it is this option. Now check the direction along 0, 0, 0 to a 0. This is a, this is a. So the direction of this, let me draw the diagram again. Y axis, x axis, this is a, this is a. Here lies 2q, here is minus 2q. Direction of dipole moment is from minus 2q to plus 2q in this direction. See, this p cap is along 0, 0, 0 towards a, 0, a, 0. Therefore, this is the answer. Though it looks big and level 2 problem, it is actually very easy problem. You have to find center of charge of q1q. Dipole moment is in this direction. In this direction is this. Therefore, this is the answer. A dipole of dipole moment P is placed in non-uniform electric field along x-axis. Electric field is increasing at the rate of 1 volt per meter. Then the force on dipole is. So electric field is changing at this rate. So to understand this, x-axis, y-axis, let me keep two charges on the x-axis. So this is x-axis, this is minus q, this is plus q. There is electric field along x-axis. So electric field at this point is 0, assume it is 0, then force equal to charge into electric field, which is equal to 0. Hope you understand this. Hope you understood this. If electric field is 0, then along x-axis electric field increases at this rate. Therefore, force on minus q is 0. Now, distance between these two charges is 2a. Dipole moment is charge into distance between the charges. Now what is the charge? Charge equal to dipole moment by 2a. Electric field is changing in this direction at this rate. So electric field per unit length equal to 1 volt per meter. What is the electric field at this point means we have to consider this length. So instead of L, let me consider 2a. Implies electric field equal to 2a into 1 is 2a. Now force on this charge. Force on this charge is 0. Force on this charge is charge into electric field. Charge is P by 2a. P by 2a. Electric field is 2a. Therefore, force on this charge is P. If force on this charge is 0, then force on this charge is P due to this increase in electric field. Consider an electric dipole placed in a region of uniform electric field. Choose the correct statement out of the following. The dipole will experience only a force. It is uniform electric field. If there is a dipole in uniform electric field, this is electric field uniform and this is the dipole, minus Q plus Q. Force on this is opposite to electric field. Force on positive charge is in the direction of the electric field. These two are equal and opposite forces. So this gives only torque and resultant force equal to 0. So dipole will experience only force. Dipole experiences only torque. Dipole experiences both force and torque. Neither force nor torque. It experiences only torque in uniform electric field. And you have derivation of this in your syllabus. That is true only for uniform. So tau equal to torque equal to P cross E, isn't it? Yes, it is this. In a certain region of space, electric field is along z direction. At the rate of 10 to the power of minus 10 to the power of 5 Newton per Coulomb per meter, means electric field is changing with respect to distance. The force experienced by the system having a total dipole moment equal to 10 to the power of minus 7 Coulomb meter in the negative z direction is. So we have to find the force. This is y axis, sorry, z axis, because it is mentioned z direction. This is another axis. This is z. Okay. Let me keep dipole on the z axis. Distance between the dipole is, distance between the charges is 2a. Electric field is along z direction. The force experienced by the system having total dipole moment equal to in the negative z direction means dipole moment is in negative z direction means this should be minus q and this is q. Because of minus q and q, direction of dipole moment is along minus z direction. So why I should take minus q and q? Here is the clue. Okay. Next, let electric field at this point be 0. If electric field at this point is 0, then force equal to charge into electric field, which is equal to 0. Now let us find electric field at this point, thereby force. electric field by distance is 10 to the power of 5. 10 to the power of 5. Distance is distance between these two points. Instead of L, let me take 2A. So electric field equal to 2A times 10 to the power of 5. Therefore force at this point is charge into electric field. Charge is 2A 10 to the power of 5. Electric field is 2A 10 to the power of 5. Charge is Q. Now let me use this equation. We have to find the force experienced. So here is the force. So F equal to, what is Q into 2A? Q into 2A is dipole moment, which is 10 to the power of minus 7. So let me adjust here only. Q into 2A is 10 to the power of minus 7. This is 10 to the power of minus 5 plus 5 equal to 10 to the power of minus 2. So 10 to the power of minus 2 is with these two. Now it is mentioned electric field is along positive z direction. This is the direction of electric field E. There is minus Q. Negative charge experiences force opposite to the direction of electric field. So force on this minus Q is in the downward direction. So this is the direction of force. See, force is downward. Downward is with negative sign. Therefore, it is 10 to the power of minus 2 with negative sign. If electric field changes with respect to distance, non-uniform electric field, then you have to solve using this method. In the previous problem also, you saw same method. Okay. Consider an electric dipole placed in a region of non-uniform electric field. Choose the correct statement out of the following. Non-uniform electric field. So if this is the electric field, non-uniform, this is the dipole, minus Q plus Q. If electric field in this region is greater, then force is also greater. Negative charge experiences force opposite to the electric field. If electric field is weak, then force is less. Observe these two. These two are not equal. So there is resultant force. So resultant force as well as these two gives turning to the dipole. Turning effect to the dipole. Nothing but rotational effect. Rotational effect means torque. Resultant force. So both force and torque. Dipole will experience both force and torque. Non-uniform electric field, both. Uniform electric field, only torque. The angle between the electric dipole moment and electric field intensity due to it on the axial line at an external point is the angle between the electric dipole moment and electric field intensity on the axial line at an external point. If this is a dipole with minus Q and plus Q, electric field at a point on the axis, let this be point P. The direction of electric field at this point is, direction of dipole moment is, see, angle between P cap and electric field is 0. So theta equal to 0. You should observe one thing. Plus Q is closer to P. Therefore, influence of positive charge is more. Influence of positive charge is more means electric field is away due to positive charge. Now, let us see the other case. this is minus q, if this is plus q and this is minus q. Okay, axis, point P. Because of minus charge closer to this point, influence of negative charge is more, therefore resultant electric field is, and direction of dipole moment is from minus q to plus q, isn't it? So minus q to plus q. So this is P cap and this is electric field E, and angle between these two is again 0. So what is the observation? If point P is closer to positive charge or point is closer to negative charge, angle between electric field and dipole moment is always 0. So it is 0. What is the difference? If positive charge, point P is closer to positive charge, electric field is away from the dipole. Negative charge, point P is closer to negative charge, electric field is towards. But in both the cases, angle between these two is 0 degree. The direction of electric field intensity at a point on the axis of an electric dipole is, the direction of electric field at a point on the axis, minus q plus q. If this is point P, electric field is away from the dipole, means effect of positive charge is more, therefore electric field is away. Now observe these four options. First option says along the equatorial line towards the dipole, it is away from the dipole. Along the equatorial line away from the dipole, we can't decide these two, isn't it? Because if this is the case and this is point P, negative charge is closer to point P means electric field will be towards the dipole. So here towards, here away. So it can be this or this. So let us check these two. Perpendicular to the equatorial line and opposite to P cap athwa or P. This is equatorial line, this is equatorial line, and then dipole moment is from minus q to plus q, minus q to plus q, perpendicular to the equatorial line and opposite to P. But electric field is always in the direction of P, perpendicular to equatorial line and parallel to P. So here it is mentioned opposite, here it is mentioned parallel to. Parallel can be towards or away. Therefore fourth option is appropriate. See, this is parallel to dipole moment and perpendicular to equatorial. In this case also, this electric field is parallel to dipole moment and perpendicular to equatorial. Fourth. The direction of electric field intensity at a point on the equatorial plane of an electric dipole of dipole moment P is, this is a dipole, this plane is the equatorial plane, minus q plus q, point P, electric field is opposite to the direction of dipole moment, this is P cap, along the equatorial line towards the dipole, this is not towards the dipole, along the equatorial line away from the dipole, perpendicular to the equatorial line and opposite to P, perpendicular to equatorial, this angle is 90 and opposite to P, perpendicular to equatorial line and parallel to P. Of course, this is parallel to P, and this is more precise. Third option is more precise. This is general case. An electric dipole is placed in space. If we move around it, we will feel this is dipole minus Q plus Q. If the point of observation moves around the dipole, then with respect to this point, electric field changes. If electric field changes, then magnetic field is induced. This is from Faraday's law, isn't it? Faraday's law as well as magnetic effect of electric current. Therefore, both electric and magnetic fields. If the point of observation is stationary, then it experiences only electric field. Because of motion, both electric and magnetic fields. An electric dipole is placed at an angle of 30 degree with an electric field. It experiences a torque equal to charge on the dipole if the dipole length is given. So they are talking about torque. So torque equal to P cross E, cross product of vectors, vector form. Magnitude of torque is PE sin theta. P is Q into 2A, distance between the charges. Electric field sin theta, torque. And torque is 2 10 power minus plus 5. Charge wanted, 2A, distance between the charges, 2 centi minus 2. Electric field is 2 10 power 5. Oh, this is torque, 4 nano. Electric field is 2 10 power 5. Sin theta, sin 30 degree. So 2, 2, 4 get cancels. 10 power 5, 10 power minus 3, minus 2 is 10 power minus 3, 10 power minus 3 to 10 power 3, 10 power 3 denominator, then numerator 10 power minus 3, sin 30 is half. So 2 10 power minus 3. So charge is 2 millicoulomb. If both the charges are doubled and distance between them is halved and gap between the charges is filled with dielectric constant 4, new electrostatic force will be. So F is constant Q1 Q2 by R square. It is given charges are doubled, so Q1 becomes 2Q1, Q2 is 2Q2 by distance is doubled, 1 by 2, nothing but R by 2 whole square, and dielectric constant 4 is filled. That dielectric constant is in the denominator because F equal to 1 by 4 pi epsilon naught epsilon R Q1 Q2 by R square, isn't it? This epsilon R is the dielectric constant, therefore 1 by 4. 2 square 4, 4 get cancels, 2 into 2 4, therefore new force is 4 times F. Two electrons are at a distance 10 power minus 10 centimeter from each other. The forces acting on them are, this is an electron, this is one more electron, distance between these two is 10 power minus 10 centimeter, which is 10 power minus 12 meter. These two are charges, therefore there is electrostatic force due to electric field, charge. Second, electrons have masses, therefore gravitational force. This distance is not less than nuclear radius. Therefore, nuclear force is absent. Only these two forces. So nuclear, Coulomb, gravitational. Gravitational, nuclear. No. No. Coulomb's gravitational. Yes. Two protons are at a distance 10 power minus 15 meter. Two protons. Distance between these two is 10 power minus 15 meter. Nuclear radius is of the same order. Therefore, between two charges there is electrostatic force or Coulomb's force. Because of masses there is gravitational force. Since distance between these two is very small, there exists nuclear force. So this distance is of the order of range of nuclear force. Therefore, nuclear force. Nuclear Coulomb, Coulomb gravitational, nuclear Coulomb gravitational. All the three are present. Two small spheres are suspended by massless insulating strings. The spheres carry identical charges. Due to repulsion, angle between the strings is theta. These two are the spheres and these two are the strings. When the spheres are uncharged, they are together because of gravitational force. Okay. If they are charged, then due to repulsion, action and reaction pair, due to these two forces, the strings will make some angle, theta. If a thick glass plate is placed between the spheres, then angle between the strings will same two strings. Because of glass plate, the force of repulsion decreases. Force of repulsion decreases means angle between the strings will decrease. This is theta dash. Theta dash is less than theta because force is inversely proportional to epsilon r. If epsilon r for glass is greater than 1, increases, then force decreases. Because of decrease in force, this angle decreases. Two positive ions, each carrying a charge q, same charge, are separated by a distance d. If F is force of repulsion between the ions, the number of electrons missing from each ion will be, look at the options, d square by e square, d square by q square, d square by e square by d square. So all the equations are different. You can apply principle of homogeneity of dimensions. Write dimensional formula for each of the terms and simplify, you'll get the answer. Force is 1 by 4 pi epsilon naught q by d square. This is from Coulomb's law. It is positive ion means this charge is positive. Positive ion is due to loss of electrons. Therefore, this q is n times e. This q is n times e. N into n is n square. F 4 pi epsilon naught d square. F 4 pi epsilon naught d square by e into e is e square. Therefore, n is root of this 4 pi epsilon naught d square f. 4 pi epsilon naught d square f by e square under root. A and B are identical conducting spheres. Initially, sphere A has minus 100 E and B has 40 E. So this is A minus 100 E. This is B plus 40 E. If the spheres touch each other, what is the resulting charge on sphere A? Since they are identical, equal charges are stored. minus 100 plus 40 is plus 60. The 60 by 2 is plus 30. Another plus 30 is here. So charge on A is plus 30, charge on B is plus 30. This share is equal since these pairs are identical. Okay, if they are not identical, then the approach is different. So plus 30 E. A, B, C are identical conducting spheres. Initially A has charge minus 50. This is A minus 50 E. B is neutral. This is B, neutral. C has 55 E. This is C, 55 E. Sphere A is brought in contact with B and separated. This is brought in contact and separated means this charge is shared among these two. So this is minus 25. This is also minus 25 because they are brought in contact and separated. Charge on this is 55 E, untouched. Later, B is brought in contact with C. B is brought in contact with C and separated. What is sum of minus 25 and plus 55? Isn't it 30E? Then they are separated. This 30E is divided by 2. Half of that stays with B, that is 15E. Another half stays with C. So plus 15E. So charge on C is plus 15E. Plus 15E.